All right, rational functions. So let's talk about horizontal asymptotes real quick. So I have, let's see, what does the first one say? If the degree of the largest exponent of the denominator is bigger than the degree of the numerator, the horizontal asymptote is the x-axis, y equals 0, why though? Okay, let's make one up. Y equals 2x squared plus 5x plus 10. I'm just making something up, guys. Completely up. X cubed plus 10x plus 100. Notice that the degree of the denominator is bigger by 1 than the degree of the numerator. It doesn't have to be just bigger by 1. It can be bigger by, as long as it's just bigger, period. So my end behavior, hopefully from your Algebra 2 class, you remember that your end behavior for the numerator is 2x squared. Your end behavior for the denominator is x cubed. So this behaves like 2 over x. So as x approaches infinity, semicolon, let me come over here. As x approaches infinity, comma, y approaches 0. And that's how you say approach. And in case you're wondering, like, okay, Chavez, what does that mean? That means that I'm converging that the line y equals 0. And the reason for that, so x approaches infinity. So x is getting larger and larger. 2 divided by 1, so check it out. Don't write this down, just listen. 2 divided by 1 is 2. 2 divided by 10 is 0.2. 2 divided, and I know that 2 over 10 reduces, but I just want you guys to see something. 2 divided by 100 is 0.02. 2 divided by 1,000 is 0.002. 2 divided by 10,000 is 0.0002. So hopefully you're seeing a pattern that as x is getting larger and larger, the y value is converging at y equals 0. So I'm going to put, so y equals 0 is horizontal asymptote. That's an A, it just came out dumb there. There we go. So y equals 0 is horizontal asymptote. So make sure that we know that, guys, and that's all just end behavior from your Algebra 2 days. Did we understand that, guys? Did all that make sense or no?
Yes.
Okay, awesome. Let's go to number 2. It says if the degree of the numerator is bigger than the denominator, there is no horizontal asymptote. And then I put y, so we're going to talk about y. If the degree of the numerator is larger by 1, the rational function has what is called a slant asymptote. And we'll talk about that when we get there. So I'll just put an awkward emoji for now. So if I have something like, I'm just going to make up a simple one here, guys. X cubed over x squared. Well, that just simplifies to x. And I really shouldn't do that right there. I should write, I'm going to put plus dot 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 plus dot dot dot. So that means that I have a rational function. And on my end behavior is going to be x, which is just, that's just x cubed divided by x squared, right? And so what does that mean? As x approaches infinity, y approaches infinity. Of course, this graph does not look like this. The end behavior does. See how it doesn't converge as x approaches infinity, comma, y approaches infinity. You're not converging in anything. And you can also approach negative infinity as well, guys. Y is going to approach negative infinity. And it doesn't, you're not converging on any number, guys. Now on this one, if the degree of the numerator and denominator are the same, the horizontal asymptote equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. Why? Okay. So this time I'm going to go ahead and just write up some random polynomial. And some students like spit in ocean and some students do not like spit in ocean. I'm going to try and explain it. And if you don't like it, I will never reference it again because spitting into the ocean is just nasty and don't do that. All right. If you spit in the ocean, does the ocean rise? Does the water level rise if you spit in the ocean, guys? Is that a yes?
What, I mean, I guess so.
So
Not that much.
Spit in the ocean, all of a sudden it's just going to go up, like boom. It's going to go up.
I hope not.
No.
Oh,
No, if you spit in the ocean, it's not going to go up, guys. So what I'm trying to say when I say spit in the ocean, we're talking about large values of x. In the numerator, the 3x squared is considered ocean, and the 10x plus 1,000 is like spit. And I could have said the same thing for number 1 here. The 2x squared is like ocean, and the 5x plus 10. So the 10x plus 1,000 is insignificant as x gets really, really large. The 2x squared is like ocean, and the 5x plus 5 is like spit. It's insignificant as x gets large. So Chavez, I don't understand this whole spit and ocean deal. All right, don't understand it. Just understand the largest degree. And my end behavior is 3x squared over 2x squared. So notice that the x squares cancel out, and you just left with 3 over 2. This is my horizontal asymptote because as x gets large, I'm going to start converging on 3 over 2. All this 10x plus 1,000, 5x plus 5, as x gets really, really large, becomes insignificant. Does that make sense to you guys or no?
So the horizontal asymptote would be 3.
3 over 2.
Okay.
You know what I mean? The coefficient of the top, the coefficient of whatever in the front of the highest degree, since they're both the same. Yes, you can just memorize that if you want to, but don't be a robot, guys. Make sure you understand. If I were to type this equation into Desmos or a calculator, if I were to make a table and I were to start putting a big number, 100, 1,000, 10,000, 1 million, I would get closer and closer. What's 3 over 2? 1.5? It would get closer and closer. I'm just making these up. I don't know what the numbers are. I'm going to say 1.48, 1.49, 1.499. So as I get closer and closer to, as I get bigger and bigger, my x values, my y values start converging at 1.5, which is like 3 over 2. Did that make sense, guys? And this is supposed to be an Algebra 2 lesson. You were supposed to cover this in Algebra 2, and I was told, they confirmed that you guys did do this in Algebra 2. So that's why I'm not going full blown here with like with the Desmos calculus to show that. But if for some reason we're having issues, please come to tutoring, and I will show you where this comes from. I have tutoring today at 4 o'clock. If you feel like you can handle some more. If you feel like you can't handle any more, guys, then just come to tutoring tomorrow. All right, so let's see if we can do example 1. It says, let's find the horizontal asymptote for the following functions. So for this function here, I see that the highest degree is a 2 in the numerator, the high degree is a 2 in the denominator. So I'm just going to go 3 over 5. So my horizontal asymptote is y equals 3 over 5. I don't know why I put an equal sign there. Let me delete that. That's my horizontal asymptote. And that's it. Because this is my ocean, 3x squared and the 5x squared. So 3x squared over 5x squared, the x squares cancel out. Does that make sense, guys?
Yes.
Yes, sir.
So now, awesome. Way to go, guys. So now, letter B, I have a 5x cubed and I have a 20x squared. The degree in the top is bigger than the degree of the bottom, so that is like number 2. And number 2 says no horizontal asymptote. Oh, okay. It doesn't say it anywhere, but now it does. No HA. Number 2 says no horizontal asymptote. So, no ha. I'm sorry, guys. That wasn't funny. I thought it was funny, but okay, anyways. Letter C. 7x cubed in the numerator, 2x cubed in the denominator. So those are like, this is my end behavior because I'm looking for horizontal asymptote. So my horizontal asymptote is 7 over 2. That's your ha. That's your ha. All right, last one here, guys. The degree of the denominator is bigger than the degree of the numerator. So that means I'm gonna have something like the situation number 1 here. And it says that y equals 0 is my ha. I'll stop saying that, guys, because I'm gonna annoy myself real quick. So y equals 0 is your horizontal asymptote. So there it is. Horizontal asymptote at y equals 0. Yeah, don't call it ha. I guess you can call it ha in the beginning, but the more you say it, the probably the, anyways, let's just stop. So I did not give you guys a packet last summer. So this is from the 2019 packet. Maybe I'll hook you guys up with that packet, guys. If you really do read it, it has a lot of Algebra 2 stuff in it. And all it says is just talks about holes. And I have some function here. And what function is that? It's this one. So I'm going to write it right here. F of x equals x squared minus 1 over x minus 1. And if I told you guys to graph this function, I would hope that you guys would expand it and that you guys would say, well, the top is the difference of squares, x plus 1 times x minus 1. And the denominator, I just have x minus 1. And as you can see, I have a factor that I have a factor in the top that's the same as the bottom. X minus 1 is there. So what does that mean? This function is not x plus 1. That means that f of x behaves like y equals x plus 1 everywhere, except where is x not defined? X equals 1. Except at x equals 1. So it behaves like x plus 1 everywhere except at x equals 1, guys. So what do I have at x equals 1 because these factors canceled out? Because they canceled out, you have a hole at x equals 1. And I gotta be very careful how I say the word hole because it could very easily sound like something else. Or anyways, so yeah, we have a hole at x equals 1, and here's the hole. If you want to know what that value of that hole is, all you got to do is plug in this value into your original function, guys, or I guess in here into what the expression is, x plus 1. So 1 plus 1 is 2, so you have a hole at 1 comma 2. By the way, the mathematical term, and maybe it's the mathematical term. The mathematical term for a hole is called a removable discontinuity. And who knows, maybe we should have called it that instead of a hole. But UH quiz does have the word hole for now, and so we'll just keep it in there for now. So whenever you get a chance, guys, maybe you guys are the type that likes to read. Well, I hope that you like to read, guys, because, you know, it's part of. Anyways, read that whenever you get a chance, and hopefully it makes sense. Hopefully that explanation made sense. If you have a factor in the top and a factor on the bottom, and they cancel out, you have a hole wherever wherever you get a 0 on that factor. And then your function behaves like x plus 1. Are we in the clear, guys, or no? Is that a yeah? You guys are scaring me. Are you guys here?
Yes, we're good.
Okay.
We're good, Job.
All right. I don't know. Maybe you guys are watching like TikTok videos or something. Let's make sure we stay focused, guys. Don't worry, we're almost done. Give the coordinates of the x-intercepts for the graph of this function. Okay, so they want x-intercepts. Hopefully this is a review, guys, because we did it in the summer. So I'm hoping that you guys will just breeze through this. So let's find out our x-intercepts. First, I'm going to factor out. I'm going to pretend that period is not there, and I'm going to put an equal sign. So there's my equal sign covering that period there. And now I'm going to factor out. So two numbers that give me 27, that add up to a 12. That's going to be x plus 9, x plus 3. 9 times 3 is 27, and 9 plus 3 is 12. Excuse me. In the bottom, two numbers that multiply give me 12, but add up to 7. That's going to be 4 and 3, x plus 4, x plus 3. We be very careful. We see that we have a term that comes, we have a factor that comes out again. So x plus 3's cancel out. And just to be, I'm going to put right here a hole at x equals 3. Negative 3. Dummy. Not you guys, me. All right. Now next. What did I want? X-intercept. The only way you cross the x-axis, the only way, and by the way, this is not how the graph looks. It's a rational function. I'm going to show you how it looks in a little bit. The only way you cross the x-axis is if the y value equals 0. So 0 equals x plus 9 over x plus 4. The only way you can equal 0, guys, is if the numerator is 0. So you don't even need to write x plus 4 in the bottom. You can just solve from this. 0 equals x plus 9, because 0 divided by anything is 0. And then move that 9 to the other side, or I guess you could have moved, well, it doesn't matter. X equals negative 9. I like to have the x on the left-hand side. So I have an x-intercept at negative 9, 0. By the way, guys, this one has a vertical asymptote at x equals negative 4. And this is the type of rational function that delta math will have. Delta math will have rational functions that are easy, and then the UH quiz will have rational functions that are hard. That's because the UH is tailored for university students, and delta math is tailored for high school students. So I don't know if you've noticed, but you probably like delta math a lot, and you probably did not have a good time doing the UH quiz. That's probably because UH is tougher. That's just the way it is. I'm sorry, guys. All right, here's the grid. And more or less, it's not perfect, but here's how it's going to look more or less. So somewhere over here, I'm going to say that's -9. There's my x-intercept. I have a vertical asymptote at x equals 4. So I'm going to say 4 is like right there, -4. Let's see. I have a y-intercept. If I plug in a 0, that's 9/4. So 4 goes into 9 twice, so 2.25. So I'm going to say 2.25 is like right there. 2.25. And do I have another 0 at, let's see. La, 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 la. What else am I missing, guys? Oh, horizontal asymptote 1. That's a horizontal asymptote. And it's going to look something like this. Since I have a y-intercept there, you do not cross this horizontal asymptote. You do eventually, you do for more advanced ones, but the ones on Delta Math, they're all basic. And I'm not insulting your intelligence. I don't think you can do, I think you can do better than basic rational functions, but just for now. Oh, there's a little error on that graph. It's not an extreme error. I just said that we have a hole at -3, and I didn't even put it in there. So here's -3 and hole. So if I want to know the value of that hole, guys, I can just plug in -3 in here, and I'll get the value of that hole. So the hole is located at -3, comma, let's see, -3 plus 9 is 6, -3 plus 4 is 1, -3 comma 6. -3 comma 6. And there it is, guys. There is my sketch. Oh. There we go. I can try, no, it's not gonna, I was gonna try and maybe erase that little dot or that little line there, but if I try to do that, since I did it all in one little whatever, it's gonna erase the whole shebang. So there it is, more or less how it looks. All right, this one here is complicated. We could probably graph it, but Delta Math is not gonna give you one of these. This is more like for UH type of thing. Anyways, it says give the horizontal asymptote. When you log into Delta Math, it's going to say to distribute everything. Don't do that. You don't need to. All you need is your end behavior. I think the reason why Delta Math says distribute everything is because they're Common Core, and they have to make sure that everyone understands. Just go 6 times x times -x. So your end behavior is -6x squared. And yeah, you can figure out the rest, but why are you going to, don't. All over x squared. X squares cancel out. There it is. Y equals -6 is horizontal asymptote. Are we cool, guys?
We're cool.
Yeah, we're cool, guys. All right, let's keep going. Identify the location of any holes in this graph of this function, -x squared minus 4x plus 32, all over x squared plus 11x plus 24. So the first thing I would do, guys, is I would just factor out this negative dude from every single one. Well, I guess I circled out 3. I didn't have to circle. Just change the polarities of everything. Negative on the outside, x squared plus 4x minus 32. Why did I do that? Chavez, why did you do that? I did that because I want to be able to factor the numerator. And it's a little more, I mean, it can be done. You can factor it with the negative there, but it's going to be a little more difficult. So if you factor out the negative, it's easier to do. So look, now 2 numbers that multiply to give you -32, but add up to a +4. I see 8 and 4 there. Negative on the outside, x plus 8, x minus 4. 8 times -4 is -32. 8 minus 4 is a +4. 2 numbers that give you 24 that add up to 11. Well, it can't be 6 and 4 because 6 and 4 adds up to 10. So it has to be 8 and 3. So there we go. They wanted the location of any holes, so I look for factors that I can cancel out. I see that I can cancel out the x plus 8, so that means I have a hole at x equals -8. Hole at x equals -8. Now they want the y value because it says the location. So when it says location, they want an x comma y. So to figure that out, guys, I'm just going to plug in a -8 into what I have left to see where that hole is located at. So let's see what we get. Negative 8 minus 4 over negative 8 plus 3, negative 8, 12, negative 12 divided by negative 5. Negative times a negative is a positive, divided by a negative is a negative, negative 12 over 5. Oh, look, we got everything we need. We got an x value, we got a y value. Negative 8, comma, negative 12 over 5. If you don't like fractions, like Chavez, I'm not a fan of fractions. I think fractions are evil. Like, all right, negative 8, comma, 5, 10, I got 2, so negative 2.4. They're both the same, it doesn't matter. I think we're good, guys. Let's put a happy face for being able to accomplish that there. Maybe give them some eyebrows. Maybe put them a little nose. All right, that's enough. Let's see, the graph of f of x equals all this stuff. It crosses a horizontal asymptote. All right, I'm gonna stop here real quick. If your teacher has ever told you that you do not cross a horizontal asymptote, I'm sure Ms. Torres never would say that. I don't think she would ever say that. You can cross horizontal asymptotes. It happens all the time in real life, especially when we're modeling like financial situations. But yeah, you can cross horizontal asymptotes. It is vertical asymptotes that you do not ever cross because you can't divide by 0. But horizontal asymptotes can be crossed. All right, having said that, this is a rational function. It is a very tough rational function to try and graph without a calculator. Delta Math is not going to give you questions like this. This is the type of question you would get on UH. Delta Math has easy rational functions because, you know, they're tailored for high school. Find the x-coordinate where this occurs. All right, so first let's find our horizontal asymptote. Our horizontal asymptote is 1/5. Horizontal asymptote is y equals 1/5. Anytime you're talking about a horizontal asymptote, make sure you say y equals. Now, if I'm going to cross this horizontal asymptote, that means this function better have a y value of 1/5. I'm going to tell you why. Hold on. 1/5 equals x squared plus 3x plus 8 over 5x squared plus 9x plus 9. All right, let me explain that again, guys. So this is not how the graph looks. So just listen right now, guys. This is not how the graph looks. Does not look like this. Pretend, we're not pretending. This is, that line right there, I'm gonna say is 1/5. That is my horizontal asymptote, because I did it with, you know, n behavior, x squared over 5x squared. If I'm gonna cross this line, if you're gonna cross that line, that y value, some x, comma, that y value is 1/5. So what did I just do? I just set the expression, here's the expression. I just set the expression equal to this y value, 1/5. So now I'm gonna solve for x. You can use any method you like, guys. You probably learned this method in 4th grade, maybe 5th, I don't remember, whenever you started doing, excuse me, cross multiply divide or cross multiply. So I think the best route might be to cross multiply here. 1 times this whole expression in the denominator is itself, 5x squared plus 9x plus 9 equals, and then 5 times the expression in the numerator is 5x squared, 5 times x squared, 5 times 3 is 15x, and then 5 times 8 is 40. And now I'm going to solve for x. If you did it correctly, not every rational function crosses the x-axis, but I mean crosses the horizontal asymptote, but this one does. If you did it correctly, the x squares will always cancel. So that's how you can tell, you know, if you did it correctly or not. From there, minus 15x, minus 15x. I'm going to move the x's to one side and the numbers to the other. So 9x minus 15x, that's going to be a negative 6x equals, and I'm going to move the number 9 to the other side, equals 31. If I did that correct, I think I did. Divide by negative 6, divide by negative 6. X equals a negative 31 over 6. There you go. We did it, guys. If they wanted to know the coordinate is at negative 31 over 6, comma, 1/5. That's the coordinate. If you go to Desmos and you type this in, and you type on y2 1/5, you will get this point. Maybe I should have had that prepared. Maybe if we have extra time, we'll do it, guys. All right, another happy face. Let's keep going. Oh, do we have any questions? I'm sorry, guys. No? You guys are pretty quiet over there. Are you guys watching a movie? Okay.
So, will there be times where it crosses two horizontal or
No, not at this level. There will be times if you're an engineer and you're looking for a specific signal of a filter, there will be times where you have infinite amount of intersections. But right here for now, we're rookies. So at the moment, it's just going to be one. Once we have more experience, we'll let your professors take care of you guys. All right, example 6. Here's how we do this one, and this one might be kind of hard. You already know it's a rational function. It's something over something. So something. Okay, what is that something and what is that something? I look for VAs first. So first, look for vertical asymptotes. I have a vertical asymptote at x equals 0. Because you have a vertical asymptote at x equals 0, you know that you have to have an x in the bottom. Why? Because you can't divide by 0. Next, number 2. Get a perfect coordinate. I see that I have a coordinate at 1, 1. So what I want the y value to be 1 when x is 1. So I know that in the numerator, I have to have a 1. Because 1 divided by 1 is 1. Now I'm going to explain that because I know some of you are saying like, what? What are you talking about? So don't write this down, just listen, guys. Just listen here. If I had a y value of 5, if that was 1, 5, then I say when x is 1, the y value has to be 5. Well, how do I get the y value to be 5? 5 divided by 1. So if I had a coordinate at 1, 5, that numerator would be 5. So at the moment, we're looking like gold. So let me go ahead and erase that 5. And what does that even mean, looking like gold? That we literally look like gold? It doesn't even make sense. All right, at the moment, we're looking good. All right, so now I observe that I have a hole. This hole is located at -1, -1. Now remember, we said in order for us to have a hole, the factor in the numerator must cancel out the factor in the denominator. So I'm going to do the opposite of that -1. So I have to say x plus 1 on the top, x plus 1 on the bottom. Notice those factors would cancel out. And I got to check, do I still get a hole at -1, 1? Yes. Once I cancel those out, if I plug in a -1 for x, 1 divided by -1 is -1. So everything checks out. So I'm going to put 3. Check that hole is correct. All right, so now how's the equation going to look? More than likely, I don't remember anymore, guys. I think on UH they distributed that. So your equation is going to be 1 over x squared plus x. Maybe they factored out the x, maybe they didn't. But there it is. There's your equation. Or it might look like this, or y equals 1 over x, x plus 1, x plus 1. It might look like that as well. One of the two. Oh, one of the two. I just noticed the first one's all wrong. X plus 1 over x squared plus x. Or x plus 1 over x factored out, x plus 1. All right, now it's correct. How are we feeling, guys? Do we feel okay?
So when you wrote y equals that first one, right, where it says under look for vertical asymptote, where did you get the 1 and the x from? Because that x plus 1 comes from the holes, right?
Correct.
That it gave you. So where did the other 1 and x come from?
Well, the x came from the fact that I have a vertical asymptote at x equals 0. And the 1 came from the fact that I have a y value of 1. So I needed to make sure that when I plug in a 1 for x, that I get a 1 for y. So if you look right, so 1 divided by 1 is 1. If that 1 would have been a 5, then I would have had a 5 in the numerator because I need the output to be a 5. So if I had 1 comma 5 as a coordinate, then 5 divided by 1 gives me 5. So it depends on what the y value is you have for that coordinate there. So if you have a 2 in there, then this right here would have been 2 over x. Did I answer your question there or no?
Yes.
Okay. All right, guys. Let's go ahead and do one last one. And this one says, determine each feature of the graph of the given function and draw a sketch. So, all right. First it says horizontal asymptote. And so they want all these. Well, I shouldn't put check marks yet. Let's go ahead and see if we can answer them. So first, horizontal asymptote. This is obviously coming from delta math because it looks a lot easier. So 2x plus 9 over 4x minus 9. I see 2x over 4x. So I definitely have a horizontal asymptote. A horizontal asymptote is going to be a half. Where did I get the half? The half came from 2x over 4x. The x is canceled out. 2 over 4 reduces to a half. And that's where that half came from. All right, next. Nothing cancels out. I can't factor anything out. So we're not even going to bother with that. Vertical asymptote. Wherever the denominator is 0. I take the 4x minus 9. Let me get some space here. Ooh, almost fell there. Let me move some space there. 4x minus 9. What happens if I fall down, guys? Would you guys just laugh? You guys wouldn't even know, right? Because I'm behind the monitor here. 4x minus 9 equals 0. Move the 9 on the other side. Semicolon. 4x equals 9. Divide both sides by 4. Semicolon. X equals 9 over 4, which is the same thing as saying 2.25. 4, 8, 1 left over, yeah. 2.25. So that's my vertical asymptote. X equals 9 over 4. All right, x-intercept. The only way to get an x-intercept is if my numerator is 0. 0 divided by anything is 0. Unless you divide by 0, then that's something special. Well, that's your whole, right? So yeah, let's not confuse you guys. 2x plus 9 equals 0. Move the 9 to the other side. 2x equals negative 9. Divide by 2. X equals negative 9 over 2, or, let's see, 2 goes into 9 4 times. 1 left over, so negative 4.5. So your x-intercept is negative 9 over 2, comma 0. There's my ordered pair. My y-intercept, that one's simple, guys. Insert x equals 0 into original. If you have it factored out, you can insert it into whatever factors you have remaining. Negative 1. 0, comma negative 1. Whole? Nope. Factors don't cancel out. And they also want a sketch. So let's do it. Let's give them what they want. Let's put a sketch in here. All right. Horizontal asymptote y equals a half. So let me draw a half. I'm going to say this is a half. Vertical asymptote, positive 2.25. I'm going to say 2.25 is like right there. 2.25, 9. Oop, that's a half. 1 half. Sorry about that. Let's see what else. X-intercept, negative 9 over 2, so negative 4.5. So I'm going to go to negative 4.50 point. I'm going to say negative 4.5 is right there. None of it is to scale, guys. It's all, you know. Y-intercept, 0, negative 1. 0, negative 1. Perfect. I'm in good shape. That's where I should be. We're not going to pass these horizontal asymptotes, not for delta math at least. And so the graph is going to look something more or less like this. And on the other side, it's going to look like that. And there it is. There it is, guys.